Hello friends, good evening. Welcome to Eastern Academy. We are into embedded system programming. A part of that, we are discussing about embedded systems. This is session 4. The last session, we discussed about the difference between board design, VLSI and embedded. And this session, we will discuss about embedded system architecture and design. So what typically how a embedded system design looks like, and what is the design you should do. Okay, that let's have a good idea before we start, so that then only you will know the importance of the C programming, which I always say. Okay, so please try to understand today. This is what the embedded system. Please understand. You have a computer built in. I have a computer built in. Understand that. I have a computer. In that, I write a program. I write a program. Then I have a input pin. I read the input pin into my variable. That's a trick. You have a pin that comes to my variable, so I can able to handle it in the program. Then I give it out to the pin. So understand. That is, I have pins. So the pin can be either 0 volt or 5 volt. Am I right? I read the pin. That is what I call input. For example, let us write a small program. Let me write a small program. I say CHAR-X. I say input and X. If you call like a scanf, like in a PC, you write scanf. If you call an input function, we're going to write that. I'm going to explain to you that how to write the input function by ourselves. Then you will understand it. That is what in our ESP program we do that. We're going to write our own input functions. Then you know that. So when I do the input, what is happening is the 8 pins can be either 0 volt or 5 volt. Minimum is 8. Please understand. You cannot read only one pin. You can read minimum 8 pins only. Then that comes to the X. If 0 volt, 5 volt, 0 volt, and 0 volt, the 8 pin. Let me take 8 pins. Easy. Let us assume that I have only one port. I have only one set of 8 pins. Then I have 8 outputs. Now, if I say that input and X, that means that here 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 2, 4, 8, 16, 32. That means that 32 plus 4 is 36 plus 2, 38. I get 38 on X. Then you will understand that, oh, if I get 38, which are all on, that will give you the clue for you. Every number gets a unique combination. From that, you will write a program now. If X is equal to 38, do that. If X is equal to 1, do that. You write a program. Ultimately, in embedded, everything is controlled by your program, not these inputs. This statement will give you only read. Same way, if I say that char X, X is equal to 10, output X, then that game will go to output. That's it. 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 1, 0, 1, 2, 4, 8. 8 plus 2 is 10. That's all you have written here, 10. It's all decimal and binary. That's it. It's a decimal to binary conversion. You watch the number system videos in our Google Drive, you will understand. So I have a computer. The computer is having 3 parts. One is microprocessor, one is ROM, One is RAM. The 3. Only 3 is the computing. Nothing more than that. Now, people put all these things also inside. That's why people call it as a microcontroller. I have a microcontroller which has input, which has output. I buy a market, I go and buy it. This is called port. This is called input port. This is called output port. You have to master only one thing. You have to master only one thing. What you have to master is this. If I tell you that, for example, if I tell you that this is a microcontroller, it has 8 input pins, 8 output pins. Now, inside the program, if you say that, if you write a small code in char X, input and X, that means that you will be reading the input. And all of them are switches. 8 switches. Understand? Now, the trick here is when I press the switches, all are connected to 5 volt. These are all connected to ground, which I told you already. Why we are getting ground, we will discuss about in electronics division. When you are this electronics session, pull down, pull up. We'll discuss later. Now I pulled it down, so it becomes 0 volt. When I press the switch, it becomes 5 volt. That means that when I don't press it, all of them are 0 volt initially. And here I connect 8 bulbs. I connect 8 bulbs. Assuming. So you should write a program here, not for the bulb or not for the switch. You should write the program only for X. I write input X. Am I right? The moment you press any of the switches, the X will change. Otherwise, X will become 0. I do now here while X equal to 0. What I'm doing now? I'm doing here input and X. See that now? What I have done? I'm in the loop always. Till X is non-zero, I'll be reading this port. I'll be waiting for somebody to press the switch. The moment you press the switch, then this becomes 1. So X becomes now 0, 0, 0, 0, 1. That means 1. So that condition is failed. Condition is failed. So it'll get out. Here I'll say if X is equal to 1, do some activity. If X is equal to 2, do some activity. Am I right? That means that you know that what switches are pressed. If you press the first and last switch simultaneously, I press this became 1. So I get here 1001. That means 129. Because 1, 2, 4, 8, 16, 32, 64, 128. I write here if X is equal to 129. Do this. Am I right? These are the way we do that. So what I'm trying to tell you now here is there is no difference between your scanf and X, and the input and X, both are same. Both are same. There you get the input from the keyboard. Here you are getting the input from the pin. If I tell you that I have 8 switches, if I tell you that if I press the 4th switch, then you on the light 4 for 5 seconds. Then on the light 7 for 10 seconds. Then on the light 1 for 2 seconds. See that? I give you the requirement like this. When I press the 4th switch, that means that 0, this become 1, 0, 8. So if X is equal to 8, Then you have to do this, all the activities. First, make the fourth LED, fourth bulb on for 5 seconds. Then off it. Then do this, do this. You understand now? This is what all about embedded. That's what you're going to learn now. That is what indirectly we are practicing on the C programming first. So before you come to embedded system programming, master the C programming. That's a trick. Now, this is a very simple, this is called generally passive system. That means that whenever you have a change, you notice immediately, and you give this guy, you do that. This guy don't have any intelligence. This guy don't have any intelligence. If you make 1, the bulb will glow. If you make 0, bulb will off. If you give a 0 means 0 voltage, 5 means 5 voltage. That's why your output will do that. Your output will make this voltage here. Your input will get the voltage. These are called passive systems. Now, the trick here is this. The trick here is, I have a small system with input and output and a computer or process. I have one more unit. This unit takes the input from you and does the activity. Let us say, I control a motor. This guy is having a software to control the motor only. I mean, this is called controller. That we have discussed on the microcontroller sessions we discussed. What is microprocessor controller? So there are two, understand one thing, in this embedded world, there are two things. One is called, you directly controls the inputs. That is, you get the input. And you directly control the outputs. These are called GPIO, general purpose input output. General purpose input output. Understand this. This is all about GPIOs. You can do anything here. You have a computer here and do the activities. You write a program. This is what we are going to do that. What we are going to do here is in the embedded system program, we will connect all the key switches, LEDs, 7 segments, all those things we are going to do that. But the second thing is, this is only about 1% of the embedded system. How much percent? Only 1%. Remaining 99% is different. The remaining 99% is active. What is the active components? We have devices called controllers. And we have devices called microcontroller or microprocessor. This game will control the controllers. Understand? That the controller will have some small memory. That controller manufacturer will tell you that what command you should give, that how he will behave. You should read this manual. Understand what to give the command. Everything is already programmed by somebody. You do not have to write a program. You should tell him what to do. He will do that. If you want to draw a circle on the monitor, tell him circle. He will do that. You wanted to fill the circle with green. Then you put circle with the green. He will do that. You do not have to do anything. You do not have to even know how it is working. That is not your requirement. Like this, you have thousands of controllers. You cannot learn everything. So there are designs like this. What happens is a very simplest design. Simplest design is this. I have a microprocessor, microcontroller, which has inputs, which has outputs. So I'll be able to take any input, I'll be able to control any outputs. I write a software directly. This is a very simple design. You master this first. This is a simple design. So we connect switch, we connect bulb. I'll tell you which switch, which bulb has to be on. This is what you are going to practice in the embedded system programming first few days. Then we start introduce to you along with the computing unit, microprocessor, ROM and RAM. We have a controller. Let us assume we have a controller called timer. So we can tell the timer that if the if an input comes, then on the LED, after 1 second, the 1 second time will be counted by the timer. Now you do not have to waste the time. You do not have to waste the time in software. Instead of that, the controller will do that. Controller is a hardware. Controller is a hardware unit, separate brain, separate computing unit. It's a separate process. Don't get confused that there is a passive, that's the active element. Now like that, let's say I connect the LCD. I can tell the LCD controller, hey, display hello. That's all. He will display hello. That's not so easy. We are going to work on a dot matrix. The dot matrix, you will start displaying ABC. Then you will know that how difficult to create a character generator. You will know that. So we are going to do the same thing in the microcontroller, but at the same time, we are going to use the controllers. So this is the way people will slowly change the design. So how we start the design is, first, master this. Have a microcontroller, have the input, and have the outputs. Don't worry about what microcontroller, all are same. 8051 or PIC or Atmega or ARM, all are same. All the microcontrollers, you just use the input function and do the output function, they work. That's it. All these things are 8-bit, but ARM could be 32-bit, 32 pins, doesn't matter for you. Otherwise, it's same. So don't worry that which microcontroller I have to practice. Don't worry about this practicing this. This is. Then you slowly add same inputs. And you add a controller called timer. You start learning a timer controller. Then you will start doing with LCD controller. Timer, LCD. Understand now? So what you are going to do in a job is there are two possibilities. The first possibility is buy a microcontroller and find out the controllers available and connect them. Controller is nothing but a job, a specific job done by IC. That's called controller. You do not have to worry. You do not have to know, like a function. Let's say you have a printf function. You don't know how the printf is printing on the screen, but you tell him %d, x, it prints. That is what the printf job. The same thing here. The trick here is this. Today, how many sensors I have, how many inputs I have, how many controllers I have to control, output, motors, everything. Based on that, I choose a microcontroller. There are microcontrollers with only 8 inputs and 8 outputs. There are microcontrollers with n number of inputs, n number of outputs. This is called port. So this is a very simple design. Then you can complicate slowly. What is a complication? Complication is nothing. You add more controllers. You add more controllers. That's the only thing complication. Okay. And more inputs and more outputs. But the problem is when you try to do all the inputs and all the outputs, sometimes you become slow. You become slow. So you have to buy a faster microcontroller. Then you should go for faster microcontroller. That's it. So this is all about speed. So initially you start with only 8 and 8, then slowly increase it to the bigger microcontroller. Okay. Then we go by the more controllers. Now, here is a problem. The trick is that sometimes the controller, what you want, let us say that I wanted a controller, this one, camera, assuming that camera controller may not be available inside your microcontroller. See, controller is a block, like a function. Now your microprocessor has to talk to this guy, outside guy. So you talk to them. Today, your job, please let me tell you one thing. What is the job of embedded system designer? You should know that what the controller functions. First, you should read what is the controller functions. Then, after reading the functions, you have to go to the controller registers. They will tell you that what to write. What to write. For particular operation. This is what your requirement today. That means that if I have let's say, let us assume that I have a LCD controller. I have a LCD controller. I connected to this guy. Now, let us say that my LCD don't have this symbol, rupee symbol. I want this symbol. Then how do I do that? If you could be able to make the symbol, which is not there in the my LCD, what I got it from the market. But I want, my customer asked me, Bala sir, I want a rupee symbol. Then you give me a product. Then you have to make a rupee symbol. How do I do that? Then what you should do is, for the rupee symbol on the dot matrix, what dot should be on? You should calculate. And this has to be sent it to this guy. This guy is having a memory. Then he will use that. That is possible. We are going to do that. We are going to, in our embedded system programming, we are going to make a different symbols on a LCD, not only the same ABC. We are going to do this. That time, you should know how to program. For that, you have to read the LCD manual. LCD manual and find out how to write. That's it. If you know how to write, then he is going to. You don't worry how he is doing. That is the difference. Now I'm trying to tell you. You don't get confused. Let us say your driver. You tell your driver, take me from Chennai to Bangalore. You don't worry. You give a command to him. He is specialized. He is a specialized in driving. You tell him and you start doing your activity. If you start finding a fault on him and if you start doing it, then you will not work. The same thing here. You tell the LCD controller, you display LCD on line 5. Let us say my LCD is 20 characters on 2 rows. You tell the LCD on row 2, column 6, display this. Then he will display. You have to tell him what row, what column, what symbol. Only 3 you should give him. That is his job to display it on there. That is not your job. How he is going to do that? It'll get, if it's not displayed there, then there are 2 faults. You have not given input correctly, or he is faulty. You have to change the LCD. For that only we call something called diagnostics. You will have a diagnostic, you will tell him what to write, 1, 2, 3. If he's not following, it means there's something wrong with the board. Then you change the board, put the new board, it will work. That's what we call diagnostics or test. So now do you understand how do you do that? That is a simple embedded system is very simple. That is on the LED and blink the LED. All those things are very simple. Then you start using the controllers. That's the way we design. So how do we design is like this? First of all, if say that, hey, if somebody says that if Balaji's face is detected, then fingerprint. Okay, then I will have a camera. Then I have a camera controller. Then I have a fingerprint sensor. Then I have a fingerprint controller. Please understand, these are all available. You do not have to create anything. Your job is to connect them with your microcontroller. Then here you connect a driver, motor, connect a motor. Now inside the program, first read fingerprint controller. If it is matched, if it fingerprint matches on motor. So what will happen? The motor will on, door will be opened. Understand? Next, read the camera controller. I'm not worried about your face. I'm not worried about your camera. Those things are taken care by your camera will convert your light. Your face, you're getting a light. Your light is getting converted to electrical signal. That's all you call CCD cameras, charge coupled devices. Okay, they convert based on the light to the voltage. And the camera controller will convert your face into numbers. It's getting numbers. That is what this guy's job. Then your software will read the numbers, then compare, then do that. Is it clear? This is what typically a design we do that. You, whatever product you want to design, you should first write it down. What are the inputs? What are the inputs? What are the outputs? You should never worry about today. Designing a product is very easy. You should know that buy a right controller, right interfaces and connect them and do everything is available in the market. But what we are looking for, that's a trick. I'm looking for you to integrate all of them and make a product. This is called product. So we want somebody, these people can connect it in the hardware. A hardware engineer will, if you tell the hardware engineer, he will buy the things and connect and give you. But you as a software engineer, read the data, numbers here, and then you should compare it and control the motor. That's why you have been paid very huge money. Understand? You do not have to do this connection. These all will be done by a hardware engineer. What you have to know is that what you will get it from the controller. You don't worry about here. When Balaji press the fingerprint here, put the fingerprint here, what I will get it here. That is what important for you. You don't worry about how this guy is processing the fingerprint. That is not your job. Same way, when a face comes on the camera, what numbers he gives you, that is how do I read it? These numbers, how do I store it in my memory? How do I check it? That is not your job. Don't get confused how this camera is reading the light to this and how I'm doing it. then enough, man. You have to start learning lot and lot. That is not your job. Your job is to insert the controller level. Your job is to insert. Please understand. Same way, you tell the motor on direction. That motor will do the thing. You do not have to. You have, let's say, 2 wires. One will tell you on, other will tell you direction. If this is 0, clockwise. This is 1, anti-clockwise. And on means it will on, off means off. You have 2 pins. You should know how to control it. So your product is ready. You bought things outside and written a software and given it out. That is what companies are looking for you. And you have to make these things as a function, such a way that it can be used for any application. The phase, whatever coming here can be transmitted to outside through Wi-Fi or Ethernet, or I can take some decision. So what today's world is like this. One is functionality. That's what we see normally. Second one is performance. Third one is reliability. Fourth one is cost. This is what important. That means that if somebody asks you to, they will, the moment you join a company, they'll give you only one thing. Hey, understand the controller, read the function and do the activity. Only one controller. First of all, you should know that you could be able to read the controller data and do that. These are all the one we are going to do. We are going to teach you on your C programming and embedded system programming, how to read the controller and everything. That is fine. Once you have done, then they will tell you that, hey, when I put the fingerprint, you are on the door after about 30 seconds. So a lot of people are waiting in the queue. Please understand, a lot of people are waiting in queue because you are slow. The moment fingerprint, why it is taking so much time, Balaji? Can you make the thing faster? That is what performance. So first time, it should open the door. That is what functionality. When I put a fingerprint here, the door should open. That is what the first one. But later, how do I reduce the time? Second. Third one is what the company will do is they will put some about 40 people or 20, 30 people or 100 people. They will do it repeatedly. I'll come and go, I'll come and go, I'll come and go. Even all the 100 times, it should work properly. That is called reliability. But for all these things achieving, you cannot just say that it costs about 1 lakh rupees. Nobody will buy it. You say that, hey, they're all good. I pay you, I cost 1,000 rupees. People will buy it. That is what cost. Now you should know that this is what the trick here. I buy this one, costly microprocessor. Buy a costly microprocessor and make the product expensive, but my software is not that good. My software is not that good. That's why this is cheap. But now the successful people buy a cheap microcontroller, but they write a excellent optimized software. You understand now why we are saying that, you know one thing, because of you write a better software, because you write optimized software, the company's cost on the product has come down. For example, the company is making about million product. One microcontroller costs you 100 rupees. Other microcontroller costs you 200 rupees. Think of it. The 200 by microcontroller 100 rupees now. So into 100. Okay, you are having 1 million product. So you see, it's about how many crores. You waste about 10 crores. But because of an efficient engineer, we make the product with 100 microcontroller. Your algorithm is very good. Your software is very good. So the company will say that, hey, Balaji has saved 10 crore for the company, man. So give him a bonus of 5 lakhs. Am I right? Give him a bonus of 5 lakhs. Understand? You know how the companies are giving you bonus. How certain employees are growing in a company. This is the reason. This field is possible, this field. This field, the moment you start doing it, you have a wonderful growth. You have a wonderful growth. That's why I've given an idea of this to you, because when we are trying to do the programming, you are not really understanding. Okay, that's why I've explained to you now what we do it in the companies actually. Sometime we'll discuss even later. Sometime we write a functions. We write a function to do that. We will ask you to use the function to make the product ready. You should do it. Nothing called. See, there is nothing called. This is the way the companies will work. Doesn't matter. The problem is sometimes when you use a function that is not giving you the optimized result, then the company will ask you, Balaji, why don't you write your own function? Make things faster. You should be ready enough. You should know, sir, I don't know how to write from the scratch. I know only using functions. That's why they don't like you to write. If you say that I know Arduino API, I know only how to use the Arduino APIs, then nobody like you. The company will ask you that, can you code from scratch? That's what we are teaching. In our embedded system programming, we discuss from the scratch, not from the only function level. Of course, we teach function also, but we teach from the scratch. Please understand the difference. Writing a program from scratch will take very long time. You always write a program from main, into main, and start writing a program. It will take very long time. But if you functions, if you know how to use functions, you will be fast. That's why we request you to learn how to use the functions. That's important. At the same time, if you say only I know functions, that's also wrong, because the ready-made functions gives a problem to you that time, or it's not optimized, or it does not have an extra function. What do you want? Then you should be able to write it yourself from scratch. That's why company will ask you, can you write a code from scratch? That means that using your pointers. Directly do that, not using the ready-made functions. That's why our code, we teach both. In our embedded system programming, we teach both scratch and function. Because you learn scratch, all microcontrollers are same. All microcontrollers are same. The scratch methodology will work. From scratch methodology will work any microcontroller. It's the same. But the function one will give you fast. Company will be happy. If you know only this, if you don't know this, then also bad. And if you know only this, and if you don't know this, that's also bad. Most of the ECE students, problem is this. You all know only scratch. You don't know how to use the functions. That's your problem. You are too technical, too detailed. We call this as a too detailed. Don't worry about that. That's not the one which industry wants. Industry wants you to be very fast. If I give a problem, they will ask you the evening. They will ask you the Balaji is ready. You should be ready by evening. The whole world is running. But Don't worry about that. This is all only initial few months or 1 or 2 years. Once you settled, this will become very easy. You will do it very well. You will teach me because I'm old guy. You people will be learning the new one. My job is very clear, man. My job is very clear. I want you to get into the company. I want to put you into the company. That's all. I want to put you into the company. Into a good company. But I'll tell you another trick. I've seen thousands and thousands of engineers. The only problem is getting into the company. Once they get into the company, they automatically learn and grow. There's no problem at all. And the company also will not leave you. After 2 years, you will jump with the salary hike of 50% or 100% hike. That's the technique is that. It is not that everybody gets this technique. I will teach you a technique how to jump every 2 years with about 50 to 100% jump. These are all some techniques. That if you know the techniques, you will do it. That's what I'm telling you. That is what fundamentals. The more you know the fundamentals, the more you grow in the industry. Please understand. That's what the trick. That is what this entire course is all about. We teach about fundamentals, how everything's work. You can interact. Maybe that's why I don't have a time limit. You can attend any of the other courses, any of the sessions, and ask you the doubts. No, you can wait, aram say, and get into the industry. Am I right? So please understand, right now you learn only this. Don't worry about these things. Right now, learn functionality. That means that you could write a code perfectly for the requirement in the shortest time. Practice. 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 Also, one more thing I'll tell you, there is no difference between C programming on computer and C programming on electronics, which you call the same embedded. Don't get confused, both are same. So right now, you master this. As I told you, next but 1 week, when you're going to start about embedded system programming, you will really know that why I'm telling that. Without practicing, don't come there, that's waste. Then you cannot do that, please. So any doubts? So that's what we do. Whenever we want to design, we will take the device first. Then we do the conversion, device and then conversion, sensor. Then we do the controller. Then connect it to the microcontroller. There you write the software. See, so many things are there. Same way output, we have a called driver or controller and to device. If it is having a direct input, GPIO, you connect a driver. Driver is nothing but amplifier. Then motor or device. Then there is an input, whatever it is. Then I have a converter and convert it to electrical signal. Switch. This is a converter. Then get the input. This is GPIO. This is via controller. Let us say I want to have a LCD. LCD is a device. Then LCD controller is a controller. Then we write it. So there are. This is the what generally we do it. You can connect any number of devices. You can connect any number of devices. You can make it design. So embedded design is not a big thing. Okay, that's a very simple. We have to identify a right microcontroller. That's the only thing. No. It is not referred the speed. It's about the microprocessor. It's nothing to do about microcontroller. 16-bit, 8-bit are all microprocessor. The microprocessor reads the data from the memory ROM from ROM or RAM. Every line is generally 1 byte. That's why you always say that my hard disk is 500 gigabyte GB. My RAM is 2 GB, 2 gigabyte. Your pen drive is 32 gigabyte. Your SD card, you say 64 gigabyte. We measured everything in a byte. Now, if this microprocessor read byte by byte, that is 8 wires, it becomes very slow. If you read 2 lines, that is 16 wires, it will become twice faster. If you read 4 lines, that means 32 wires. If you do 8 lines, it will become much faster. So this is a number of connections. Also, for example, let us take, you are a good, multiplication. I mean, we all human being knows multiplication. You know only single digit multiplication, 16 to 9, you will know that. You don't know 16 into 19. You don't know. You will do that 60 to 9. It takes so many processes. By chance, you know 2-digit multiplication, then you are faster. And if you know the 4-digit multiplication, how do you multiply this? It will take very long time. But by chance, if you know 4-digit multiplication, you will read it 1 second. If you do 8-digit multiplication, see 8-digit. That is what the trick here. The 8-bit microprocessor knows only 8-bit into 8-bit. But if you try to do 16-bit by 16-bit in 8-bit microprocessor, it will take very long time, like you. But 16-bit microprocessor will do the multiplication very fast. 32-bit will do much faster. That's a trick. Okay. So that is what 16-bit, 82-bit are the microprocessor, what you are inside, the microcontroller, the data width, and internally what is the size of the ALU, how they do the process. They are handling 8-bit or 16-bit or 32-bit at a time. It refers to exactly the speed, that is how fast. That indirectly tells you how fast it's going to work. Am I right? Any other doubts? Okay then. Thanks a lot. The videos will be available to you by about 10 o'clock on the recorded the drive which I've given you. Okay. And the most important thing is these lectures can be heard by you anytime and make it a master. And anytime you want to discuss with me, we will do that. But the most important thing is mastering the C programming. So please spend your time. All you people, I request always spend your time on mastering it. That's a trick. This is very simple. This embedded system field is very simple. Even both the design as well as writing a software. The only problem is we underestimate the programming by 2 ways. First, we are underestimating that, we are overestimating first. Oh, because somebody told in the college everywhere, the software is too tough. That is also wrong. But once you enter, you underestimate this becomes so too easy. No, you have to practice a lot. I'll tell you that we conduct sometimes we conduct the online interview for you. I'll do the interview every student. I do the interview. Anytime you can come back. That time I will ask you to share the screen. I'll give a new problem. And on the spot, you should be able to think and write the program. Then you will know that how good you are. That's why I wanted. Okay. Oh, RC circuits are having lots of variations. The accuracy, that is called PPM. You just go and search called PPM, parts per million. That means that if my frequency is 1 megahertz, if I say 10 ppm, it means that the variation will be 10 hertz out of 1 megahertz. Whereas RC dot, if there's a small temperature change, that oscillator will change totally the clocks. They are not accurate at all. You never get accuracy clock in RC dot. Resistor and all will change based on the heat and the temperature. Okay, which never happens on the crystal. That's why we use crystal oscillator, which has a huge accuracy. Sometimes we get even 1 ppm. Think of it. You are very expensive, but you get very accurate things. Basically, it's a very natural phenomenon. They found it. The crystal, when you cut it at the right angle and you give an apply a voltage, it starts vibrating. It's a beauty one. That's a natural beauty is crystal oscillator. But somehow, engineers, you have to thank all the engineers. When we were studying in a school, and I was studying about 9th and 8th, talking about 1970s, I think about 50 years back. Those days, we used to get the crystal oscillator, make a radio. Transistor radios, we built it. All. When once it receives a All India radio station, you'll see that happiness what we had. I built my own microprocessor, studying in the college using breadboard. We built our own microprocessor in 1983. When you talk about how many years, 40 years back. 40 years back, myself and my friend built our own microprocessor using breadboard. The joy you get it is too high. Let me stop the recording. We can discuss anything.